and as soon as it connects, you can click on the thing, and we have readings for temperature, turbidity, and the parts per million in the water. And if I hold the temperature sensor and increase the temperature as the website updates, the temperature will rise until it gets to a point where the TDS module would stop working, where it shows a warning that the water temperature is too high. And for the TDS module, the percent is clarity. It's over 100% right now because it's outside of water, but when it's in water, it should be 100. And if there's parts like this thing going through it, it would decrease down, and depending on how.
So our presentation was the water warden. Our team is stmhotbox, and we're team number 26. So he has it holding up right here. So the water warden utilizes the Raspberry Pico 2W as its brain. It can take in various metrics from different sensors. There's a TWS sensor, a turbidity sensor, and a temperature sensor. The temperature sensor accounts for, as the water temperature shifts, the data from the turbidity sensor also shifts. The temperature sensor accounts for that. So here's our reference list. You can see our basically where our pinout are from the Raspberry Pico. And then the project is run on MicroPython, which uses 6 different libraries, and they're all in the standard firmware. So we are hosting a web dashboard that displays the temperature, the raw turbidity value, and the water clarity percentage. This page will automatically refresh every 2 seconds. So why we didn't use AI is that AI in the cloud may solve your problems, but it doesn't solve ours. Utilizing AI for water saving measures simply shifts blame, because it goes from you discarding water to us discarding water. By not utilizing AI, you miss out on excessive water wastage, increased operating costs, and an additional point of failure. And our next steps are probably going to be to integrate additional sensors, stuff like pH sensors, dissolved oxygen sensors, and stuff like that. Dissolved oxygen is important because it can cause oxidation in silicon fabs, which is very detrimental to silicon purity. We also want to create a different movement system, either continue with the boat cell architecture and introduce some kind of mechanism for it to autonomously move, i.e. a LiDAR sensor, or possibly introduce a Core XY system with an attached probe. We also want to unify it, manufacturing custom PCBs that can reduce cost and increase versatility.
So semiconductor manufacturing requires ultra-pure water, and although we can't test for the precise levels of dissolved solids and other stuff that need to be in the water, we can disqualify certain kinds of water for processing and refiltering into ultra-pure water. This is by detecting turbidity, or TDS, as already seen in our device. And we can also classify it based on the TDS level into whether it's being used for boilers or whether it can be recycled for use in coolers. However, this has not yet been implemented.
And then these are our links and resources. Thank you.
Thank you. That's okay, I can edit the other one.